Okay, so I gave you this question at the end of the last video. So it's a household size distribution. 27% of households are single, and 34% of households have two people, and 16% have three. Blah blah blah. And it's interesting. One good thing about the median is that it does not matter five or more. Does not matter. Anyhow, the median will be somewhere in here. Five or larger does not matter. There can be like, say, even if there is a household with 100 people, well, that does not change the median. Okay, so the median household size, to calculate the median, you first need to calculate the cumulative probability by accumulating the probability from the smallest. It is easy. This mechanical, like 27 plus 34, and 27 plus 34 plus 16, 77, and add up the number, the probabilities. In the end, you get 100. Should be easy. And then you have to find the values over 50%. CDF, cumulative probability greater than 50% are these four values. You choose the smallest, that is 2. So 2 is the median. It is that simple. Okay, so now I am going to illustrate how to calculate median from Excel. Let me, I'm not sure, maybe let's move it here. Uh, so I have data, this is raw data. Raw data from 2010 census population. There are 51 states, including District of Columbia here, right? Um, and I guess most of you know this, but when you need to calculate the mean, you use average function. Like you can type up this from B column from 2. B2 is this cell down to B column 52. B52 refers to this cell, like a column by row. And if you connect by colon, right, then it chooses all the things in between them and close the parentheses. So it's a function you get like this. Or in case if you are really new to Excel, you may use formula. Here you can find things like you can check what you need. There are some like functions like absolute value, sine and cosine, things like that, and auto sum, average, max and mean, count numbers. Like if you click average here, you may sum, or depending on what you want, like average. Of course, like say choose a cell. Here you are going to put average here and find the function you want, like average, and then drag the area of the numbers you calculate average over. Then press enter and you get the average. Average is again 6.5 million. And how do you calculate the median? You may use insert function again. I don't know where the median is, so I will just click this insert function thing and search median. You don't need like from the category search median, then you will find several functions. Especially I'm just using median. And choose number, click this and drag those area and you will get this number. This happens to be Kentucky, right? As I explained in the slides, the population in Kentucky is the median because Kentucky is exactly in the middle, at the center of 51 states, right? So Excel will calculate that for you. Okay, so anyhow, like whatever you want, you can just choose from the insert function thing, like search what you want, like a maximum, Excel has a lot of functions that will be very useful if you learn them. Back to slides. I will now, so like here, up to here, I explained how to calculate the median when you have raw data and when you have probability distribution table and Excel. Are pretty straightforward. And I will discuss when it is a problem. To think about that, let me give you an interesting quiz. There was a survey in 1986 at the University of North Carolina about their starting salary of the class of 1984. Right? So, guess at this time, it is in the 80s, guess at which major had the highest average of starting salary, right? So it's like 2 years after their graduation. Guess. And the answer is geography. Geography, right? It's surprising. I believe nobody would choose geography, but national average was 22,000. But at that time, geography from North Carolina University was 250,000, 10 times larger than the national average. How is it possible? Because of this guy. In case if you don't know who he is, he's Michael Jordan. You may have heard about his name from like shoes, and he graduated from like geography in the North Carolina University. Because this guy happened to choose geography major, the average was 10 times larger than the national average, right? Then this is the problem of the average. Average it can be contaminated by one person, one observation, literally. So, good pros and cons. Mean is really widely used, easy to compute, very intuitive, has many nice like mathematical properties, and anyone can understand. So it's really nice, right? However, it could be misleading if there are outliers because average is severely affected, very sensitive to outliers. Like you see this example. His one outlier will cause a big difference. On the other hand, like median is exactly the opposite. Median is very less sensitive to outliers, very stable, right? So, however, it's less popular, less tractable. Mathematically, not that tractable. So, my suggestion in general is just use the mean. Mean is always the first option to choose, but when you use the mean, keep this in mind. Be careful and check if there are outliers or check the median to see if the results, if your conclusion changes when you change to the median, right? So, and if the mean and median are different, that means they are outlier. There are outliers. Okay. So, back to our state population example, like California and Texas are outliers. We may see this by simple numerical examples, like so this is average. I will like put it this average and median when you have 51 states. And what I'm going to do is I will copy, I will take average excluding California, right? Only from Texas to Wyoming, right? So I dropped California and like median. Also calculate median without California. It's like when you analyze the state population, you may think that California is an outlier. It behaves differently from all the other states. So let's exclude one. That makes sense. Like for example, when you analyze like international trade, usually the United States is an outlier. Like, you know, almost every country suffers from like recession, but United States is doing well. Like all the other countries would like to lower their interest rate, but United States is too strong, so they cannot because the exchange rate will suffer. Anyhow, so in that case, if you think one unit is different from the other unit, then it's reasonable to drop one unit like this. California is dropped. Then now you see the difference. When you drop one state, average changes from 6 to 5.4. It is nearly like 10% change, but median changes much smaller change, right? So that is the difference. Like now you may do similar test by excluding Texas too. Now I am excluding two states. I think Texas and California are outliers among the states, so I will drop them in our analysis. Let's drop them and see. So then median changes by zero point 0.2, but average changes again by zero point 0.4, like another huge difference. And as you drop the outliers, the median and the average will get closer to each other, right? Because the difference, you can think that the difference between the average and the median are coming from those outliers, right? So as you drop more outliers, the median and the average will be similar, right? So this is exactly what I did. I drop one. It's an experiment. I drop one outlier, the biggest state, and I drop two biggest states and see how sensitive the mean and median are. And median is less sensitive to the change, right? Of course, both drop because I'm dropping the biggest states, but the how much it drops are different between the mean and the median. So then, like we can draw some conclusions. By comparing the mean and the median, you can guess where the outliers are. If outliers are on the lower side, so if you believe that there are extremely small observations, right, compared to the most of the other observations, then in this case, these extremely small outliers drag down the mean more than the median, right? So mean is much smaller than the median. On the other hand, this is exactly what we just saw. When there are extremely large states, large outcomes, then they drive up the mean more than the median. So mean is greater than the median. So as the difference is larger, that means the outliers are much larger or there are more outliers. So the effect of outliers can be shown from the difference, right? So, and this is particularly important in economics because we have a lot of outliers in economic data, right? In natural science or engineering, how many outliers are there? Like think about distribution of height and weight. I have never seen who is twice taller than me, right? The difference between me, like from like say Wembanyama, it's not double. He's much taller than me, but not like double of me, right? And also in engineering, you never see like 10 times larger products. Like I have a like say battery. If it's too large, that is a problem. But it's the error is really small. Small error matters, but anyhow, you don't see like double the size by error. But in economics, we see rich people who is like 1,000 times richer than me. I don't know how many times, a million times, could be a million times richer than me. Like who is like Warren Buffett, Elon Musk, Jeff Bezos, like Bill Gates. They may be like million times or wealthier than me, possible. And like among the firms like Apple, like Microsoft, Amazon, Google, Nvidia, they behave totally differently from most of the firms, right? Their size is just uncomparable to the average, right? And also, stock market crashes. When it crashes, it's totally different. It's outlier observations. Like it may drop, I don't know, 30% a day, things like that. But usually we don't see like more than 10%, right? But it may drop on a few days, it crashes. So these are outliers we observe in economic data. That is possible, and not just possible, it is common, pretty common. So you have to be worried about them. For example, this is an example. It is from New York Times. So we believe that GDP is growing steadily. That is true. But GDP per capita is on average. You calculate the sum of production divided by the number of people. That is exactly the average. So the GDP, real GDP per capita increased like this since 1975 from like until 2009, right? Like financial crisis at the end. Anyhow, it increased steadily. That is right. However, it doesn't mean the median is increasing. On the other hand, the real median household income is pretty flat, did not increase as much. That means the average increased a lot because those who are already rich became even richer, right? Elon Musk like earned a lot, but I didn't. Still, the average increased a lot because of him, right? So So this shows why the average can be dangerous, right? Still, growing GDP growth is important. I'm not saying it is useless. It is important, but it's not everything. As an economist, you should think about inequality, distribution, and the shape of the distribution, and the potential shortcoming of the average, like how much it can mislead, right? As you see, it's like a real median household income increased only by like 20%, while uh, GDP grew by like 2 times, nearly doubled. Okay, so here median is like this. So I will, in the last 5 minutes, I'm going to generalize the idea of the median. So I define median as the value that divide sample into half and half. Okay. Then by changing the ratio half and half into other ratios, we may find more measures like this. You can divide sample into 25 to 75, right? We call that 25 percentile. This means the bottom 25% value. Or you can divide the data into 75 in the bottom and 25 in the top. That is 75 percentile, which means the top 25% value, right? So you can do it for any probability between 0 and 1. So p% to 100 minus p, divide the sample into that ratio, and you can have different point, right? Right? This is called percentile. P%, it's not minus, I just wanted to show. P percentile, probability that x is smaller than or equal to p percentile is p%. Of course, actually the detailed definition is more complicated than this, and there are two different formulas, but I'm not going to explain that here. That's minor issue, but just I want you to have the idea, right? So we may generalize the idea of median to other percent, and then it's more general. So 0 percentile is the minimum, and 25 percentile is referred to as first quartile, right? When you divide the sample into four blocks, then the first one is 25 percentile, and the second quartile, third quartile are by 20%, 25% increment, and 100 percentile is the maximum. So this measures not the center, but relative standing. It's like ranking. 0 is your rank, minimum. and 100% is your maximum. You must have seen like standardized percentile score. Like in if you take an exam, like then your score is given to the relative ranking, given as a relative ranking to the all the exam takers, right? So this is particularly interesting and important in economics because we have to care about the shape of the distribution, how the bottom behaves, how the top behaves. Like the top is those who are rich, and the bottom is the poor, right? So we use this idea in many examples like value at risk in finance. So we care about the expected return, but we have to worry about like stock market crashes. Like so we are thinking about what is the worst 5% case. That is 5% value at risk, right? What if like if you think about the worst 5% scenarios in the stock market, then how much we can get? That is value at risk. Similarly, infant growth rate, right? So, for example, when I tell you a 2-year-old boy is 25 pounds, it's not that informative. I like my son. I have a younger like a kid, but still I don't remember how heavy he was when he was 2 years old. So this is not informative because I don't know what is the average boy, 2-year-old boy, how much they weigh. But if I hear he's at 25 percentile, for example, then it's informative. He's growing at this pace. He's lower than the median, but like bottom 25%. So not much to worry about. Something like that. So this is an example. And also, you must have heard about 20-80 ratio. So compare the top 20% to the bottom 80%. So it's income inequality measures, right? So how much the ratio, the wealth for top 20 and bottom 80. So it's also based on the relative standing. Finally, standardized score, right? So if I tell you, say a test score, my son got like score of 55 from his school exam. I don't know what that is, so but how good he is. But if the teacher tells you like he's like 60 percentile, that means he's above the average. So relative standing may convey more informative information than just the original random variable itself. So from the median, you may extend your uh, idea to more general cases. I'm not going to discuss detailed mathematics behind them, but it's good to know, right? So thank you for watching. This is the end of chapter 3. I will see you in chapter 4. See you later.